Welcome to this online workshop, An Introduction to Authoring. In this workshop we will discuss two topics, namely author functionalities and an introduction to authoring, where we will create a chapter, a theory page and an open exercise together. If you wish to click along during the workshop, you can go to cloud.sowiso.nl and log in. Some schools may need a different link to log in, but your Sowiso contact person will tell you about that. Before we start, I want to give a quick recap of the class structure we have at Sowiso. If you log in and go to Home, on the right you can select the class that you want to see on the left. In this case we have selected the Basic Maths Demo class. And on the left you see all the chapters that are in this class. If you click on a chapter, you see the contents of that chapter, which are either subchapters or the theory pages or packages that are in these subchapters. So the ones with the paper icons are the theory pages, and the ones with the pencil icon are packages of exercises that are about the theory that's discussed in the theory page above it. And on the right here you see a number that indicates the number of exercises that are in this practice package. But what we will mostly talk about today is the authoring environment of the platform, which you can see if you go to the Author tab up here. If you cannot see the Author tab, make sure you've selected the Author role here on the right. And if you cannot select this role, please contact your Sowiso person to help you fix this problem. Now, first of all, I want to show you some examples of pieces of content, and the first one is a theory page. This is an example of the theory page sandwich rule for limits, and up here you can see the chapter which the theory page is in, which is limits, and you can see that this theory page is in the subchapter calculating with limits. Now you see that we can type some text here, and we have these building blocks that can contain, for example, a definition or a step-by-step solution or an example. We can have images or videos. This image is a GeoGebra applet, but you can also upload images from your computer. And you can see that we can type LaTeX fonts up here, including colors. And then at the bottom of the box, you can see that we have some expandable boxes, for example this one. And we use them to make the page look less cluttered and to hide information that may not be really relevant for every student. At the bottom of the page, we have an example. You can see here the question and then the fully worked out solution. And at the bottom, the student can click New Example and they get a new example to show. For the exercises, there is different exercise types, about 28 of them to be precise, and most of them are mentioned here. They're not all equally relevant. The ones in bold are actually the ones that are used most. And I'll show you examples of those. So this is an example of an open type exercise, meaning that students get one or multiple of these answer fields, where the student can type any number, mathematical expression or logical expression. Then this is an example of the exercise type Dropdown, where the student gets a dropdown and he has to click one of the options. Then the exercise type Open Free is a combination of the open fields that we saw before in the open type exercise, the dropdown fields that we saw in the dropdown exercise, and also text fields. We don't have to use all three of them, we can only use two or one of these options in the Open Free exercise. Then we have a multiple choice exercise, where students can select one or multiple answers, and one or multiple answers can be correct. And here you also see that we have used GeoGebra applets, but again, you can also use images from your computer. And this is an example of a radio button exercise, where the only difference with multiple choice is that at this time students can only select one answer. So the options are with a little bullet instead of with a little square. And then we have the exercise types radio button and radio button random, and also multiple choice and multiple choice random. The only difference is that if there is random at the end, then the options are displayed in a randomized order. Then we have a drag and drop exercise like this one. Again, we use GeoGebra applets, and here students have to drag the derivative to the right function graph and solve the exercise like this. We can also have drag and drop without images. So for example, this one where students have to complete a proof Then we have exercises like this. These are GeoGebra type exercises, so we use a GeoGebra applet to make the exercise. Here, for example, students have to relocate points to draw the function with a sine function in it. Then we have some non-mathematical exercise types, for example the exercise Python, where students have to type some piece of Python code and also run it in the platform, and the code is automatically checked. And we have, for example, drawing molecules exercises, where the student has to draw the product of the following reaction. In almost all of these exercise types, we can have automatic grading, which means that we can implement partial scoring in tests, we can give tailored feedback to the students' mistakes, and we can give context-specific hints. And I'll show you this in the open type exercise that we have seen before. So here we see a function, and because I am the author, I have this yellow button that says preview, which I can click to see a preview of the solution. For this one, the answer is 10/7, and if I type that, you will see that it is seen as correct. What the student could do, for example, is they could calculate the right limit, but then not simplify it enough. For example, by typing -5 - 5 over -5 - 2. Then the platform will recognize this and tell to the student to simplify their answer. So this is an example of something that we could give partial automatic grading for. For example, 75% for a mistake like this. Then another nice thing about these exercises is that every time the student reloads the exercise, they get a unique attempt because we use random parameters in the exercises. And again, I can show you the example of the open type exercise. So if we look at the function here, we have x to the power 3 plus 4x squared minus 25x minus 100. So if I reload the exercise with new variables, this function will change, also the limit will change, and the answer will change. So now it's not 10/4, but it's -4. And if I reload the exercise again, the answer will again be different, as you can see here. And that means that the student can keep practicing the same exercise over and over again because he cannot remember the answer from the last time he did the exercise. Before you actually start making some content, I want to talk about exercise sets. So I've told you before that every time we can make the exercises such that every time the student reloads the exercises, they get different numbers. So basically a different exercise. And that means the numbers in the exercise are randomized with variables. Now sometimes we don't want this. For example, in these two exercises on the right, you see that they're both about a linear approximation of a certain function f. And we want the function f in the second exercise to be the same as the function f in the first exercise. And the way we can do this is to put these exercises together in an exercise set. Which means that there are two different exercises, but the variables of these exercises are shared. And the way you could recognize a set in a package is that the bullets of the exercises are linked with a little line in between. And we will get to making variables and making sets when we actually start making the exercises, but just know that exercise sets are not the same as exercise packages, because an exercise package is just a collection of exercises on the same topic. And then there are some things we have to think about when using online tests. The first one is that it is harder for students to score points in a digital exam. We can help them by, for example, enabling automatic partial grading, or by allowing students to make either notes by typing text or letting them upload a photo of their physical notes to the exercise in a test. And the second one is that it is important for students to answer using the right syntax. If we look at this example on the right, you see that the student gets asked to calculate an oblique asymptote, and the answer is y is x minus 6. But if the student will type x minus 6 without the y equals, then the platform will not recognize it as being correct. So it will give the feedback that the equality sign is missing. And also here we can help the student by putting in the text, in the question text, how they should answer the question. For example, here it says give your answer in the form y is ax plus b. and this should give the student enough information to correctly fill in the test. Now we will create a class with some content in it. So first of all, we have to create a new class. The one you see now is basic maths, but we will create our own class. And to do this, we go to the teacher tab. Now we click manage and we click new class. I will name it Amber's class. Select the faculty, for example this one, and then an end date. Let's say this one. So if I go home now, it will say, sorry, you do not have access to any content. And that is because we haven't actually added any content to our class yet. So we will do that now. And to add some content, we have to create some content first. So we will create a chapter. And to do that, we go to the author tab. We click on chapter, and then we click on new. First, we have to select an author group. And an author group is basically a way to keep track of which person can see which material. You can be added to an author group in different roles, for example with write access, which means if you have write access to an author group, then you can write exercises or theory pages or content to that author group, and you can also delete content or change it. You can also have read copy access to an author group, which means that you can only see the materials that are in that author group and copy them to your own author group to make changes, and there's also different types of access. But here you will see a list of all the author groups that you have write access to. So I'll select my own. This is an author group to which only I have access. Then we give the chapter a name, for example, materials week 1. We put the status on published, which means that students will be able to see it if I add it to a class, and these last two can remain unchanged. So now we've created a chapter, and you can see here that this is the name of the chapter, and this number is the ID number of the chapter. There can be multiple chapters with the same name, but the ID number is always unique. So if you want to find your chapter, make sure you remember the ID number of your chapter. Now what we have to do is we have to add our chapter to our class. So we again go to the teacher tab. Then we click on course materials. And then here we have to search for our chapter. And I click and drag it to my class. And you can see it's added here. So if I go home again, I see an overview of my class, and you can see that I have added this chapter, materials week 1. So what we want to do now is actually create a subchapter in this chapter, and then create a theory page, a package, and an exercise for in the package that we can add to this chapter. So again, we go to author, and this time we click subchapter, and we again click new. And then this one can, for example, be limits. We select the position that the subchapter should be in. So again, I look for my chapter that I just made with the right ID number, and I click published. So right now I've created a subchapter called limits. If I go home, I don't see the subchapter yet because there's only one subchapter in this chapter, so it's automatically hidden. But if I create another subchapter, then you'll actually see them. So I will do that now. Subchapter. Now we've created another subchapter in differentiation, and if I go home now, you will see these two subchapters in my main chapter. And pieces of content like theory pages and packages can only be added to subchapters. So you'll always need a subchapter in your chapter to add some content. So right now we will create a theory page. And again, we go to the author tab. And now we go to theory. And I click new again. I will name my theory page example theory page. And again, I have to select where this theory page should be. So I select my chapter. and then either of the subchapters in this chapter. And I changed the status to published, so students will be able to see it when I add it to something. And then you see the edit theory page. So here we can actually write our theory page. And this is just an HTML editor. To review the HTML source code, we can click this button. And you can figure it yourself. And then you see the page where we can edit the theory page. So here we can type. This is basically an HTML text editor. And we can start writing the theory page. And if I save it, I can click on preview to preview the theory page the way that a student would see it. So I see the location of my theory page, the name of the theory page, and then the text that I typed. A nice thing we have is these blocks. So let's add this part to one of these blocks that we saw before. To do that, we select the text and we click on Formats, Theory Blocks, and then pick either of these, for example, definition. And if we save it, this text will appear in a definition block. Definition. Then we also had these expandable boxes that you could click on and then some theory would expand. So we will make these as well. We can select the text, click Formats, and then expandable blocks and pick either of them. And save again. Now we see our definition box with an expandable block with the text that we have selected. Now what we can also do is show example exercises on the theory page. And to do that, we first need to actually make a Sowiso exercise. We will do that in a bit. But let's say I have already created the exercise 907707. That's the ID number of the exercise. And to show this exercise as an example on this theory page, we use SW_example. And then put this exercise between brackets. If I save it, this exercise will now be displayed as an example on my theory page. As you can see here, this is the exercise, the open type exercise that we have seen before, including the question and the worked out solution. And if I click new example, the computer will select new numbers. And if I want to add multiple exercises, we can use a comma and then type another ID number. Now there's plenty more options for the theory pages, but you can find them yourself by just clicking at the different menus and seeing how it works. If you click on these two arrows, you can see the HTML source code in case you want to edit something in the source code itself. Now if we go back to the home screen, we can actually see our theory page in the subchapter that we made. And if we click on it, we see the theory page we just made. So now we want to make a package of exercises that is on the topic of the theory in this theory page. So again, I click on Author to make a package. Then I click on Packages and I click on New. Here I select the type of package, mostly practice, and I give it a name. And again, I select the position where the package should be. And I change the status to published. So right now my package is empty, but I can add exercises to it. For example, the one that is an open exercise about limits. And to find my exercise, I either type the name or the ID number of the exercise here in the search bar, and then I click on the plus sign. And you'll see that the exercise appears here. And if there is multiple exercises, for example, two of the same, we can actually change the order by dragging and dropping. So if I go home, I can see the package that I just made and I see a 1, which means that there's only one exercise in this package, namely the open exercise that you have seen before, this one. But now we want to add another exercise. So we will make an exercise by going to Author, clicking on Exercises, and then New. So the name I will give to the exercise is Adding Numbers. Again, the status should be published, and the type is the exercise type that we want to choose. So right now I choose the exercise type Open, because this is the most frequently used one and also the most flexible one in my opinion. And then we click Next. In case you don't know what exercise type you want to use, you can click this button Manual, which will open the exercise manual. And you can see here an overview of all the exercise types with a description, and if I click on one of them, it will show an explanation on how to make them. This is one of the many help pages that we have, and at the end of this workshop I will get back to all of them. But now we've decided that we want to use the open type exercise, so we click Next. And here you see the Edit Exercise page. So we have different tabs, and we start with the Text tab, which shows all the text that a student should see at some point. So for the title, for example, we choose Adding Numbers. We don't have to add a title, but we can. And then the question, for example, very simple, simplify 3 plus 5. And as you can see, I've used these hashtags here. And what that means is these hashtags are LaTeX delimiters. So anything that is between these hashtags will be displayed as a LaTeX text. We can also use the backslash square brackets to make equations appear centered on a new line, like this. Okay, so we've typed the title, we've filled in the question, and then we need to type the solution text. So I type 3 plus 5 equals 8. And note that what you type here in solution is only the text that the student sees when they click solution. This is not what the computer uses to check if the student's answer is correct. That is done by the solutions tab, but this is just the worked out solution. So if I click View Exercise, I can see what this exercise would look like for a student. And you can see here the title, the ID number of the exercise, and the question text. And if I click Solution, I will see the worked out solution that I typed. Now we have two more fields here, pre-input and post-input. And what that means is that the pre-input will show up before the answer field, and the post-input will show up after the answer field. So in the pre-input, I could, for example, say 3 plus 5 equals. And then this will show up before the answer field of the student, as you can see here. Now, if I type the correct answer to this exercise, namely 8, then the computer will say that this answer is wrong, because we haven't actually told the computer yet what the correct answer is. And to do that, we go to the Solutions tab up here. And we have to input the correct solution to the exercise. And to do that, we first have to select an evaluation type to compare the student's answer with the correct answer. As you can see here, there is a whole list of evaluation types, which are all explained in the Help Center, but we will use the default one, which is eval normal. And the way this evaluation type works is it will compare whatever is in the definition field here with the student's answer, and if these two values are mathematically equivalent, then the computer will say that the student's answer is correct. So if I type 8 here, and I view the exercise, any answer that I type that is mathematically equivalent to 8 will be seen as correct. So if I type 8 here as a student, it will be correct. And if I type something that's not mathematically equivalent to 8, it will say wrong. But the problem here is that if we type, for example, 3 plus 5, that is also mathematically equivalent to 8, so that will also be seen as correct. And this is something we don't want, because the student didn't actually solve the exercise. And to solve this problem, we need positive feedback rules, or actually feedback rules in general. And the way feedback works is explained in this graph. So this is the feedback system for the evaluation type eval normal, which we have selected in our solution. And the first thing that the computer will do is check if the student's answer is mathematically equivalent to the solution in the solution step. If the answer is yes, for example in the case of 3 plus 5, then the computer will check if there is a positive feedback rule applicable to the student's answer. In our case, this is not true because we haven't actually made any positive feedback rules, so none are applicable to the student's answer. And in the case of no, the computer will say that the solution or the student's answer is correct. What we want instead is that there is actually a positive feedback rule applicable to the student's answer. For example, one that checks if the student has used any symbols in our answer. And then we want to display this feedback rule to the student. They will get an orange check mark, meaning that they did the exercise correctly, or they did a correct step, but they're not finished yet. So we will now make a positive feedback rule. We go back to the edit exercise page and we go to positive feedback and we add a rule. And again, we have to choose the evaluation type. And in this case, we don't want to choose eval normal, but we want to check if the student's answer contains a symbol. So I look for contains symbol and I select that one. Again, if I click on the eye or if I look at the help center, I will get information on how this evaluation type works. But the way this one works is if we choose the evaluation type contains symbol and we leave the definition field empty, then this feedback rule will be triggered with any symbol in the student's answer. And then if this feedback rule is triggered, we can give the feedback text, for example, please simplify further. And don't forget to save your answer. So if I view my exercise now, and I type an answer that is mathematically equivalent to 8 but contains a symbol, for example 3 plus 5, it will give me the feedback, please simplify further. And because I am an author, I can also see this yellow button that says positive feedback rule 1, referring to the positive feedback rule 1 that I just made, please simplify further. And if I type another answer that is also mathematically correct, or mathematically equivalent to 8 but contains a symbol, then this will get the same feedback, whereas 8, which does not contain a symbol, will still be correct. Now it could happen that there is multiple positive feedback rules applicable to the answer at the same time. For example, if we add a rule that checks if the student's answer contains a variable. This positive feedback rule is triggered if the student's answer contains any variable, and if that is the case, the feedback text your answer contains a variable will show up. Now as you can see in this graph here, if there is multiple positive feedback rules applicable to the student's answer, the computer will display the applicable feedback rule with the highest priority. So if we go back to our feedback rules, we see a button priority here. And 0 is the highest priority and 99 is the lowest priority. So if, for example, I change this priority to 10, and this one stays 0, then rule 2 has the highest priority. So if I type an answer that is mathematically equivalent to 8 and contains both a symbol and a variable, then feedback rule 2 will show up. And we can check that here. So I type an answer that is mathematically equivalent to 8, but contains a symbol and a variable, like this one. Then positive feedback rule 2 shows up because that one is the highest priority. If we now change the priorities, for example, we make rule 2 a priority of 20, then rule 1, which is priority 10, has the highest priority. So if we type the same answer as we did before, rule 1 will show up. As you can see, now positive feedback rule 1 shows up. Please simplify further. because that rule now has the highest priority. As you can see in this graph, there is also negative feedback, which is what the computer looks at if the student's answer is not mathematically equivalent to the solution in the solutions tab. And the same method applies here. So if there is one or multiple negative feedback rules applicable to the student's answer, the computer will display the negative feedback rule with the highest priority. And if there are no negative feedback rules applicable, the computer will just say wrong. So right now, if I type an answer that is not mathematically equivalent to 8, the computer will say wrong. But we want to change this. We want to make a rule, for example, that checks if the student's answer is almost correct. So if it is anything between 7 and 9. To do that, we go to the negative feedback and we click Add Rule. Then we again have to select an evaluation type, and here we choose Eval Numeric. With the Eval Numeric evaluation type, we have to put the correct answer in the definition field, which is 8. And then we can either write a precision or write a low and high range, in which our student answer should fall to trigger this negative feedback rule. If I select a precision of 1, then any student's answer between 8 minus 1, which is 7, and 8 plus 1, which is 9, including the boundaries, will trigger this feedback rule. And as a text, we will say, your answer is almost correct, please try again. So again, I view the exercise and I type anything that's between 7 and 9, for example 7. It will show me your answer is almost correct, try again, and it will also show, because I'm an author, that this is negative feedback rule 1. And if I type something that's very wrong, or that's outside of 7 and 9, it will just display wrong, which we saw here in the graph. Now another thing that I mentioned about exercises is that every time we refresh the exercise, the numbers can change. And in this case, that doesn't happen. The numbers stay 3 plus 5. And to make the exercise randomize, we actually have to change the numbers 3 to a variable that has a certain randomized value. And also we have to change the number 5 to a randomized value. And to do that, we go to the Variables tab, where we need, in this case, 3 variables, namely one for the number 3, one for the number 5, and one for the solution, which is the sum of these two numbers. So we add 3 variables. And then in the definition field, we type some kind of PHP code that defines this variable. So for example, if I type this, then this variable will have, as a definition, some kind of random integer between 1 and 9, including the borders. And this variable is right now called $A, but if I want to change the name, which I suggest if you have a lot of variables, then I can click on $A and give it a new name. For example, number 1. For the second number, we do the same. So again, this will be a random integer between 1 and 9. And we will call this variable number 2. And then for the last one, this variable should be the sum of the first one and the second one. So here we can type number 1 plus number 2. And as you can see, 4 plus 9 is 14. And if we click new variables, the computer will generate new variables, but the sum will still be correct. And this last variable we call solution. So right now, if in the text, for example, or in the solutions tab or any of the other tabs, if I type either $A or number 1, then the computer will replace this value with the number 3. So right now we will replace the fixed values that we have written down with our variables. So everything where it says 3, it becomes number 1. And everywhere it says 5, we have to change it to number 2. And we do that in the other text fields as well, where 8 should be changed to $solution. And now we have to go to the other tabs and also change all the numbers to our variables. So in the solutions tab, we don't have 8, we type solution. In the positive feedback, we actually didn't use any numbers, but in the negative feedback we did. We can have to change 8 to $solution. And if we now click on View Exercise, we will see the exercise that we made before, but now with randomized numbers. So this time the numbers are 3 and 6, but if I reload the exercise with new variables by clicking on this blue button, we actually get new variables. And the solution will change every time. So if I click on preview, I see a preview of the correct solution. This time it will be 12, but if I refresh the variables, it's now 14 and so on. And as you can see, this blue button will refresh the exercise with new variables, but we can also restart the exercise with the same variables by clicking on the orange button, like this. And the white button will show the variables that are in the exercise. So we will see $A or $1 is 5. The second variable has value 9, and the third variable, which is the solution, has now value 14. Note that we can also make variables using Maxima, Python, or R, which are all programming languages. And if you're interested in that, you can go visit our help center, and there's articles that explain exactly how to do that. Now the last tab that is interesting is the General tab, which can be found here. And here we can change, for example, the name of the exercise. We can change the status from published to either unpublished or deleted. And we can change the exercise type and the number of input fields. So if I click here, I can change the exercise type. But I would suggest that before you change the exercise type, to actually make a copy of the exercise by clicking on this copy button. Then choosing an author group and clicking New Set. And then change the exercise type of the copied exercise to prevent any data from being lost. Then here we can choose the number of input fields. So right now there is 1 input field, but we can change it to 10 just to show you the difference. If I now click on View Exercise, you can see that there is 10 input fields that all have their own pre-input and post-input and also their own feedback rules and solution, which can be useful sometimes. And then there are some more options you can change. For example, you can change the author group that the exercise is in. So this is a small summary of how to make an open exercise. So now we have constructed this exercise about adding numbers from scratch. And we want to add it to our package that we have made before. To do that, we go to the home page again. And we click on the 3 dots next to our package that we want to add our exercise to. We click Edit, and then we see the Edit Package menu again. Another way to get to this menu is by clicking on Author, clicking on Packages, and then finding the package with your right ID. So this one. And you can see that our open example exercise is still there, but we want to add the exercise that we just made. And as you can see here on top, the ID number is 110741, which is here. So we click on the plus to add it. And then we drag it upwards because we want this to be the first exercise in our package. If we now go to home again and refresh, you can see that right now there's 2 exercises in the package. And if I open it, I will see first the exercise that we just constructed. And then secondly, we will see the open example exercise. Then to end this workshop, I will tell you where you can find more information about authoring or the Sowiso platform in general. So the first place to find information is in the General Help Center, which you can access by going to help.sowiso.com. You'll see the Help Center like this, and you can search for articles that have information that you need. For example, if you forgot how the open free exercise type works. Or if you want to know how to make variables using Python. And these articles explain how to do things step by step in a very detailed way. So this is a good first source for information. Then secondly, you can find information in the more detailed technical authoring manual, which you can access by going to this link or by going to the author environment by clicking on the author tab and then clicking on the manual button in the right top corner. Here you can see tabs on the top and tabs on the left where you can find information. For example, an overview of the evaluation types of an exercise and how they work. Then you can choose Sowiso example exercises and maybe copy them to your own author group just to make some changes or to see how we made some kind of exercise. Then we have the YouTube channel with some videos on, for example, authoring or the teacher environment where you can... Another thing you could do is request access to exercises that are made by Sowiso authors, just so you can see how certain types of exercises are made internally in Sowiso. Another option is to go to the YouTube channel, which looks like this, and there are some playlists with videos on how, for example, authoring works, or the teacher environment, or the student view. Here you can find the same information as in this video and maybe a bit more. And then lastly, if none of these sources gave you the answer to your question, you can contact us at support@sowiso.com and we will get back to you as soon as possible. Thank you for your attention and good luck with creating your own content and exercises in the Sowiso platform.